Now, let's look at the second example. The second example, this example, you can do this in two different ways. Okay, you can do this in two different ways. One way is like this. Is an easy way. Very easy. Before I do this easy way, I want to show you how to use this by using Heron's formula. Okay. Now, in a triangle, if you have a B, if you have a C, if you have an alpha in between, you can find out A by law of cosine, right? Okay. And then, that will be like this. A squared is B squared plus C squared minus 2BC times cosine 65 degrees. Okay, you can see here, if it's B here, C here, alpha should be in between. Okay, alpha is the angle in between those two sides. Okay, that's necessary. Alpha cannot be here or here. If it's here or here, you cannot use law of cosine. All right. Yeah, it has to be an alpha, an angle in between these two sides. So we know actually all the values alpha, B, C, we plug in 5 squared, 45 squared, minus 2 times 5 times 45, 2 times 5 times 45, and then cosine 65 degrees. The answer comes up is 1859.821782. Okay. Now, you want A, you don't want A squared. And A is 43.12565,109. Approximately is 43.126. Well, you need the answers to do decimal places, at least during the middle steps, you want to keep 3 digits. Otherwise, your answer may not be right. Okay? Now, you need S. How do you find out S? You add all 3 sides together. B, this is A, so A, this is A, plus B is 5, C is 45. Add together, divided by 2, you have a 46.56282555. Approximately is 46.563. Because you can round this one. Greater than 5, round it up. Okay, so you have S. And then, using the Heron's formula, S times S minus A, that's A, and S minus B, that's B, and then S minus C. Okay, all together, choose the square root, and then that will be 101.9596263. And then if you need 2 decimal places, you round it up. This 9 is greater than 5, so you have a 101.96. This is using Heron's formula. Okay, there is a quick and fast way. As I said before, right down here, if you know B, C, and alpha, you can use this formula. Okay, so down here is that you can use the formula right here. The area equals 1/2 B, C, sine alpha, that's 1/2 times 5 times 45 times sine 65 degrees. Okay, so it's quite quick. And then you see you have a calculator here. Okay. Let me move this up a little bit. And then this one can be down a little bit. Okay. So we do 1/2 later. We then have 5 times 45 times sine 65 divided by 2, 1/2. See, 101.96. Okay, 101.96 approximately. Okay. You see, the answer is the same. All right. So I will mark this one. This is page 7. I may mark here is 7B. I say here is 7A. All right. Now, this one is let you try yourself. You have alpha, beta, B. How are you going to find out the area? Okay. And look, you know alpha by law of sine, so you have sine alpha. You have a beta. Okay. You have a beta. Beta is right here, sine beta, so you put the value here. You have a B, so you can find out A. Okay, you can find out A. After A comes out, then you know alpha plus beta. Alpha plus beta plus gamma is 180 degrees. So you plug in those two values down here, you can find out gamma. Okay. Now you know you have a AB and the angle alpha in between. You can find out area. All you can do is find out C. Okay. You have a B right here. You found A. And then you can also find C. Okay, and then find out area by using Heron's formula. Okay, you have A, you have a, using this formula you find A. Okay, after beta comes, delta, alpha, beta, gamma comes out, then you can find C, you know ABC, you can find out area. Okay, or you find out area directly. If you have a gamma, then you have A times B times sine gamma, and divided by 2 will be the area. Okay, so there are many different approaches to do this one. Try this one yourself. Okay, I think that's the end of the lecture for the Heron's formula, and I'll see you next time.